continuing with how to find missing sides and missing angles in non-right triangles. We talked about one method to find those missing sides and angles was to use the sine law. However, the sine law can't be used in every situation. For example, this question. Here's all the information I've given you. I've given you two sides, the angle between them, and I've asked you to find the third side. Is there any way that you can set up sine law to find B? Well, what would one of the fractions be when setting up sine law? One of the fractions would have to involve B, wouldn't it, little b?
B divided by sine.
Yeah, so we know that's going to be one of them. And then the other fraction has got to have a side that we know and an angle that we know. So if I used 11, do I know the angle opposite 11?
No.
Can I figure it out?
Yeah.
Really? How?
No idea.
Don't you need to know two angles to find the third?
Yeah.
There's not enough information for me to find angle C. So I can't use 11 over sine C because I don't know what this is. For the same reasoning, I can't figure this out. So I can't use 5 over sine A. If I try to use 5 over sine A, well, I end up with two unknowns. You can't solve an equation that has two unknowns. I mean, you can, but other things have to happen. Okay? So my point is there are certain situations where we need another formula to help us, and something called the cosine law was developed in order to answer questions like this. And cosine law is kind of it's a mix between using right triangle trigonometry and Pythagoras. You will get these formulas, or really you only have to know one formula for cosine law. Technically there are three. Here's cosine law. If we take a side, so little a, and we square it, it's going to equal the following. It's going to equal one of the other sides b, little b squared, plus the third side, little c squared. So that's the sort of the Pythagoras part. Minus 2 times that other side, times the third side, times the cos of the angle opposite the side we're trying to find. Before you freak out, it's not that difficult to figure out. Okay? Because I'll bet you, if you just look at this and follow the pattern, how would you go about finding b squared? How would you do that? What would be the formula for that, now that you know this one? Minus a squared plus c squared minus 2ac cos b. Good. If one of the sides is squared, then the other two sides are on the other side of the equation. We square them and add them, and then we multiply both of them by 2 times the cos of the angle opposite the side we're trying to find. So if I wanted to try and find c, well, c squared is equal to what?
B squared plus A squared.
B squared plus a squared.
Minus 2.
Minus 2.
C.
Really?
No.
Follow the pattern.
Why is
BA times cos, capital C. So one of the questions before we start doing a couple of examples, how we use these, okay, is how do we know when to use sine law, when to use cosine law? Here's how I like to do it. There are only two situations where we use cosine law. We're given two sides and the angle between them. We're asked to find the third side. You have to use cosine law. The other situation, you're given all three sides. You have to find one of the angles. So see if it's one of these first. If it's not, then sine law. So if not, then use sine law. So what you do is you eliminate cosine law or you use cosine law.
We'll get these formulas?
You will. You'll only get this one because that's all you need. Because all these are basically derived from this one. Okay, so let's go back to that example. Notice the situation, two sides and the angle between them. That's cosine law. Okay, two sides, angle between them. So we have to use cosine law. So we got to set it up. Well, b squared equals, now take one of the other sides.
8 squared. Oh, 5 squared.
5 squared
Plus 11 squared.
plus 11 squared minus 2
5
times 5
times 11
times 11 times the cos of the angle opposite. Yes.
Can you just plug this into calculator?
So notice that we're not actually solving an equation here. Well, I mean, we are. We're solving for b. But it just, all we have to do is calculate all of this using order of operations and take the square root at the end. So let's do that. So I'm going to get an approximate answer here. What's 5 squared? Plus, what's 11 squared?
121.
Minus, now do all this whole thing on your calculator and usually round it to one decimal place. So do 2 times 5 times 11 times cos 65. Give me the answer rounded to one decimal place.
Next.
Well, it's mine, just, it is going to be a minus, but just do this.
46.
Yes. Okay. Now let's put all these together. Add 25, 121, and subtract 46.5.
99.5.
99.5. And then to get b by itself, we just take the square root, and you're asked to round it to one decimal place. Well, you might be able to do it without a calculator. 10. Because 99.5 is really close to 100, and the square root of 100 is 10. That's how we find a side using cosine law. How do we find an angle? Well, this is going to involve more equations, though. Notice this situation, and not the situation out on Langside. Okay? We're given all three sides and asked to find one of the angles. We're asked to find angle C. So, how do I set it up? Would you all agree that at the end of the formula, I'm going to have this, right? Because it's what I'm trying to find. Well, if this is at the end, which of the sides goes here? Little c, which is 18. Now that you've got that one, you can fill in the rest. This must be 11 squared plus 15 squared minus 2 times 11 times 15. Now we've got some solving to do because we've got to get C by itself. Okay? Well, first of all, let's simplify the numbers. What is 18 squared?
324.
324. 11 squared
121.
plus 15 squared.
225.
Okay? And I could multiply all these into a single number. 2 times 11 times 15.
Negative
Minus 330. And don't forget there's still a times cos C beside. We could add these two together.
121.
Yes, gives us
346.
346. Now, this is where a common mistake happens. Students think that this is this. They just subtracted 346 by 330 and then put the cos C on the end. You cannot do that because these are not like terms. If they both had cos C's with them, you could put them together. But because this is just 346 and this has a cos C attached to it, we cannot do this. No way. What we have to do is we have to take this over to the, remember, we're trying to get C by itself. So I need to take this over to the other side by doing what? Subtracting 346. And what does the equation look like after I do that? I should get negative 22 equals, and what's on the right-hand side? Negative 330 cos C. Divide.
Negative 22.
No.
Oh, sorry.
You're right, divide. But what do we divide by? I want to get rid of this.
Negative 330.
Divide by negative 330. So I get negative 22 divided by negative, well, which is actually just the same as positive 22 over 330.
0.06.
You don't even have to do it. You don't even have to do that. You can if you want, but you don't have to.
Oh.
Because what's the last step to get C by itself? To get rid of just the cos. Cos inverse both sides. So therefore, C is going to be the cos inverse of 22 divided 330.
43. I got 42.
Try that again. Anybody else want to take a shot? 86 degrees is correct. So those are the two situations where cosine law comes into effect. Two sides and the angle between them, or all three sides. And notice when you're finding the missing angle using cos, it does involve a little bit of work. You've got to know your algebra skills. Okay? The next page, just like I did with sine law, is just a proof of cosine law. You don't need to know this, okay? Really, and like I said before, we get that cosine law formula by splitting the non-right triangle into right triangles and using Pythagoras and right triangle trig to make a formula that works every time. That's really all it is. But I would like to look at this one. Okay, we're golfing. And we're on the 8th hole, and the distance from the tee to the 8th hole is 348 meters. Okay? So on the first shot, Herman drives the ball so that it lands 195 meters from the tee. However, if he slices the ball so that it doesn't go straight, if you're right-handed and you slice, your ball goes off to the right. If you're left-handed and you slice, your ball goes off to the left. So that's what slice means. So we'll assume he's right-handed. So let's draw this situation. Okay? We've got the green. Right there. We've got the pin.
It's really nice.
Okay.
Actually, it's really nice.
It's a red flag, which means that the pin is up front. In case you didn't know that about golf, there's 3 different colors to flags on the pin. Red flag means that the hole is actually closer to the front of the green. White flag means it's around the center. Blue flag means it's at the back of the green. Okay. We got a tee box. Okay. We know that from here to here is 348 meters. Okay. However, when Herman hits the ball, he slices it so that it goes off to the right. And we know that it lands 195 meters from the tee. We also know the angle of the slice. Or, sorry, from the tee, not from the hole. I'll put that in the wrong spot. Somebody should have corrected me. We also know that the angle the ball went off at. It went off at 12 degrees. So right now, his ball is here. After the sliced tee shot, we need to figure out how far is he from the pin. So I need to figure out this distance.
Okay, 8 squared. No. 2 sides.
Is it cosine law or sine law?
No, sine.
Why is it cosine law? 2 sides and the angle between them. What's that? Yes, but I could give you questions where you're still going to have to figure that out. It is the cosine law. So the unknown side is this. So d squared equals what?
D really.
Tell me what to put in.
Equals
Yes.
woo!
195 squared
What's
Yes.
the big number?
minus
Yes.
2
Yeah.
times 348 times 195 times cos d 12 degrees. Take that one off.
Good. Bless you.
Let's do.
Said it first.
Let's
Bless
do.
you.
I beat
Thanks.
you at 5.
Jenks, you owe me a Coke.
No, I won.
Okay, so yeah, we got some big numbers.
348 squared is 121,104. Let's do. I win.
Here, stop it. 195 squared?
I got this.
Oh, this is approximate.
38,025.
38,025.
What's the right hand?
That's a big
Now
number.
this one, just go one decimal place, put it on your calculator, round it to one decimal place.
I haven't wrote down those numbers
I
yet.
got this. 348 and 195 close 12. Oh my goodness gracious. Minus 132,754.2.
Good.
754.
No, 132,754.2.
Yeah, I was reading the last digit.
Oh, how am I supposed to know that?
Anyway, let's add these two and subtract.
Got it?
Get a single number.
121 4.
Use your inside voice
My bad.
or your inner voice.
She's got it.
I have no doubt.
26,370. Am I rounding it to
Oh, one decimal place.
26,375?
One decimal place.
So 74.8. So why can't I just make it a full number?
Because it's not allowed.
Ugh.
Could you just plug everything in your calculator?
Like do it all here?
Yeah.
Sure.
Okay, I also got this.
Nearest meter.
Okay. Hundred.
162 meters. So that's how far he's from the pin.
Wow. I feel like we could have just.
How many of you have golfed?
Me?
Have you ever used a rangefinder?
Yes.
It's like a little thing where you can line it up with the flag and it tells you on the screen how far away you are. I mean, it's using this. It's using trigonometry to
Could
figure
I
it
just
out.
like pull up my math book and
Sure,
I
Yes.
could do that?
absolutely. If you've got like a protractor to measure your angle, how much you went off,
Uh-huh.
and if you've got like one of those,
Protractor.
what's that?
That's a big protractor.
No, it doesn't have to be big.
On the hole where your ball is?
Okay, you don't need to do the whole thing. You can just do the part right at the tee box. Yes. Like, you don't need a protractor that has to go like this. Okay? A protractor that goes like this will be sufficient. Will still be 12 degrees.
Really?
No, really.
That's crazy.
I know. Okay.
It's hot here.
It is, I'm cooking.